Hello and welcome. I'm Dean Cobalt, and in today's episode, we are going to be talking about phases of matter. Now, the phases of matter are liquids, solids, and gases. And there's also a fourth phase called plasma. We're not going to talk about plasma today in this episode. We're going to just stick to the three basic phases. And we're going to talk about the phases from a chemistry point of view, from a molecular atomic point of view. But before we talk about that, I'm going to talk about a distinction between amorphous and crystalline substances. So, crystalline substances are substances that do not, or that do have a long-range repeating pattern, or they're highly ordered. So they have a long range repeating pattern. So there's a lot of order to them. This would be things like salt, so salt crystals, and as well as diamonds. Both of those are crystalline solids because they have a long-range repeating pattern, and they're highly ordered. The other category is called amorphous. Now, what does this word mean? It comes from the Greek. The A refers to not or no. It's the negative for in the Greek. You see this in a lot of words. For example, atheist. So the atheist, the A in atheist means not. It's the negative theist. So one who does not believe in God, right? So that would be an example. So amorphous, morph, comes from the Greek for shape. So no shape. So a shapeless substance, right? No order to it. So this would be no long range repeating pattern. Okay. So those are two distinctions you want to make. Now, an examples for amorphous would be things like rubber, glass, plastic. Those would be examples of amorphous substances. Okay. Now, the next thing I'm going to talk about is the phases of matter, solid, liquid, and gas. So I'm going to erase this. Okay, let's talk about solids, liquids, and gases. Okay, so solid, liquid, gas. Okay, so let's start with solids. I'm going to draw a picture of what solid looks like at the atomic level. And if you looked at a solid at the atomic level, you would see tightly close packed atoms and molecules in the substances. And that is what gives the solid its characteristics. So from an atomic point of view, the atoms or molecules are closely packed, and they have fixed positions. So the fixed position means that they're not going to move from place to place. they don't have any locomotion, meaning, or another word is translational motion. So they're going to stay in the place that they are. That doesn't mean that they have no motion at all. It just means that they don't move from place to place. They will vibrate. So vibration is a motion that they have, and that'll be important when we talk about heating stuff up and energy and things like that. So they're closely packed, fixed positions, and they vibrate. So let's write that down. So they do vibrate, but they don't have locomotion. No locomotion. It's also called translational motion. Okay. So what about liquids? So if I draw a picture of a liquid, then you're not gonna get as nice of a pattern so they're going to be not as closely packed as a solid, but really when we're talking about the difference between liquid and solid with respect to how closely packed they are, there's not much of a difference. So they're still closely packed. However, the difference is going to be now you can have locomotion. So there's no fixed position. They do have locomotion, so they have locomotion or translational motion, so they can move around. Okay, so so if I draw arrows in here, so the atoms or molecules can move around, but they're not going to move away from each other, right? So in this case, the intermolecular forces, and we'll get to that in another episode, the attractive forces are still strong enough that keeps them pretty close together. They're not going to be moving away from each other unless the liquid evaporates. But that's going from liquid to gas, and we're going to get to gas in just a moment. Okay, so the attractive forces here are so strong that they keep tightly packed together, and they're not going to move from their place. Here, the attractive forces are not as strong, so there's some motion involved. They get to move from place to place, but they're not really going to move away from each other. They're going to still be pretty tightly packed, but they have room to move. Here, we only have vibrational motion. Okay, now what about gases? Gases, if I draw a picture of a gas, so here you can see that the gas particles are very far apart relative to liquid and gas, or liquid and solid. So here there's a lot of space. So here the attractive forces aren't holding them very close together, so they can move away from each other. So here, not closely packed. Okay, so they're not closely packed. There's no fixed position. They can move away from each other. And so these are going to be what the characteristics are from a molecular or atomic point of view. So how does this translate into the properties that we normally see of these solid, liquid, and gas? What are called like macroscopic properties. One property of solids is that they have their own definite shape. They have a definite shape, and they have a definite volume. So I'm going to write that down here. So they have a definite shape, and they have a definite volume. And the reason that they have a definite shape and definite volume is because they are fixed in place. They don't move around, right? So the definite shape, definite volume just means that their volume and their shape does not change. And that's because the volume doesn't change because they are very closely packed. So the volume isn't going to change. The shape isn't going to change is because they have a fixed position. So the fact that they have a fixed position and they're locked into place means that they're not going to move around. So they're going to keep their shape. The shape is not going to change. And the fact that they are closely packed and can't move around means also that they're going to have a definite volume. The volume's not going to change either, right? So they're going to stay pretty close together, right? They're not going to change as far as how closely packed that they are. And also, because they are already so tightly packed, you're not going to compress them anymore. They're already as packed as they can be. So they are not um, compressible. So not compressible. What about a liquid? So we said a liquid, the molecules or atoms can move now. So they still are pretty tightly packed, but now they don't have a fixed position. They can move around. How does that translate into the properties of liquids? Well, one of the things we know about liquids from our own experiences is that liquids flow. They spill out of their containers, right? You notice that when you put water into one glass and transfer it to another glass with a different shape, the water fills the shape of the container, right? Um, but we know that liquids don't change their volume. So if I have 500 milliliters of water, if I put it into a 500 milliliter beaker, it's going to fill the 500 milliliter beaker up to approximately the 500 milliliter mark. If I move the water 500 milliliters to a graduated cylinder, a 500 milliliter graduated cylinder, then it's going to have a different shape because the cylinder has a different shape than the beaker, but it's going to fill up to the 500 milliliter mark in the graduated cylinder. So for liquids, it's going to have no definite shape. Right? So it's going to fit the shape of the container it's in. It's going to have whatever shape the container has, it's going to have that shape. Why? Because there's no fixed position. The molecules can move around, so they can fill in the shape and move around to fill in whatever space is available, right? And gravity is going to help that out as well. So there's no definite shape, but there is still a definite volume. Okay, so there is a definite volume, and that's because they're still very closely packed to each other, right? They're not going to move away from each other. They're going to stay pretty much in contact with each other, but they can move around past each other. Okay, and because of that, liquids are also very non-compressible. You're not going to compress the liquid all that much. You might be able to compress it a little bit, but really not a lot. So, for all intents and purposes, it's not compressible. So not compressible. Okay, well, what about gases? Gases have a lot of space between them. We know from our experiences that you can compress gases, right? So you can squeeze a balloon and make it smaller with the gas inside. Why is that possible? It's because you have all of that space in between the molecules or atoms. They can move away from each other. They can be brought close together. And because the gas molecules can move away from each other, now you can have any volume you want. So the gas can fill up the volume of any container whatsoever, regardless of the volume. So the volume is going to be the volume of the container as well as the shape of the container. So there's no definite shape. So no definite shape. And there's also no definite volume. It can have any volume of whatever container it's in. So no definite volume. And it's compressible. So okay, so that is an explanation of solids, liquids, and gases, the phases of matter from a molecular atomic view. I hope you liked this video. Please like the video, subscribe, and make a comment in the comment section if you have any questions or if you want me to go over anything else. I'd be happy to do so. Thank you very much for watching.